Today's video will be learning how to draw Lewis dot structures for ionic compounds and determining the formula of an ionic compound using the Lewis dot structures. Okay, let's start off. In order to do a Lewis dot structure, we need to know how many valence electrons an element has. And this table here is going to illustrate that. At the top here, these are my group numbers. Okay, so these are my groups. Oh, my pen's going a little crazy there. Those are my groups, and they illustrate the number of valence electrons. So every element in this group has one valence electron, every element in this group has two, etc. 6 valence electrons, 7, and 8. The Lewis dot structure drawn for an element is simply a way for scientists to express important information about an atom's electron cloud using a simple picture. Okay, and it's only going to show us the valence electrons. So, how many valence electrons does chlorine have? Well, if I go back one slide, alright, there's chlorine right here. Okay, go up to the very top of the group and I'll see it's in group 7, indicating 7 valence electrons. I'm going to draw my Lewis dot structure showing those valence electrons. These dots here represent the valence electrons. So any Lewis dot structure is simply showing the outer edge of my electron cloud, the valence electrons. There's examples here. Sodium is located in group number 1, therefore it has 1 valence electron and 1 dot representing its outer shell electron. Magnesium is located in group 2, and therefore you see 2 outer shell electrons, and chlorine is in group number 7 and has 7 outer shell electrons. This is an illustration of the first 20 elements of the periodic table and their electrons. And you'll notice that all the elements in group number 1 have 1 dot or 1 valence electron. All elements in group 2 have 2, 3, 4, 5, 6, 7, and in this case 8. There's an exception to the octet rule right here. Helium only has 2 in its outer shell. That's alright. So if you check this out, nitrogen and all the elements in nitrogen's group all have the same exact electron cloud on the valence shell, 5 outer shell electrons. And we tend to draw these electrons in 4 places. I call it 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. Now in order to do ionic compounds using a Lewis dot structure, we first need to know how to do it using the elements alone. Now we're going to start combining them together to form Lewis dot structures for ionic compounds. Once again, this is simply a simple way for scientists to express important information about the formation of my ionic compound. Okay, and the key here is showing the valence electrons only. Simple expression. This is the electron cloud drawn simply for sodium, and you'll see that it has 2 electrons on its inner core, 8, and finally it has 1 electron in its outer energy level, and that electron is going to be represented by 1 dot. Chlorine has 7 electrons in its outer energy level, and we're going to represent those electrons by the 7 electrons you see here by 7 dots. Now, in order to complete my Lewis dot structure, what I really need to do is show how my electron is transferred over to chlorine in that fashion.
A few moments later.
Conception. Physical body rather than an area of probability where electrons may be found at a specific time. Some models show the electron cloud as solid physical balls. Models that can lead to misconceptions about bonding. Misconceptions can arise from teachers' oversimplification of bonding models and use of analogies that lead students to the idea the bonds are physical structure in a molecule. A teacher may avoid teaching difficult or abstract concepts because they do not understand it clearly themselves. Remedies encourage students to actively confront their faulty notions through student-centered learning activities to assist in reformation of bonding concepts.
Students access prior knowledge of bonding and build upon them. Careful and thoughtful use of teaching language and analogies. Students see electrons in Lewis dot diagram as static bonding electrons as they physically join to another atom. Encourage more self-directed learning since most misconceptions are the result of simplified teaching. Research about misconceptions indicates a strong relation between the use of conceptual joysticks and the correction in the student's understanding.
In this video, we'll write the Lewis structure for SF5-. We'll take a look at the bond angles and the molecular geometry. SF5- has 42 total valence electrons. We'll put sulfur in the center. It's the least electronegative of these elements here, so we put our sulfur, and then we're going to put 5 fluorines around it. We'll place a pair of electrons between each of the atoms to form chemical bonds, and I'll just use a line to show that pair of electrons. At this point, we've used a total of 2, 4, 6, 8, 10 valence electrons, and you'll note that sulfur has more than 8. That's okay. Sulfur can have an expanded octet. Next, we'll put electrons around each of these fluorines here to complete their octets. So right now, each of the fluorines has 8 valence electrons. The sulfur has 10, that's okay, but we've only used 40. So we're going to place the last 2 valence electrons right here on the sulfur. And that completes the Lewis structure, and sulfur can have 12 valence electrons. If we look at the molecular geometry, we can see these fluorines, they're all going to spread out and push away from each other. And then this lone pair up here, it'll do the same. And that'll look something like this. We'll add 5 atoms, 1, 2, 3, 4, 5, and you can see they're all spread out from each other. And then we're going to add a lone pair of electrons. That lone pair pushes all of these other ones down, stays up here just like in our drawing, and we have bond angles of 90 degrees. The molecular geometry is called square pyramidal. This is Dr. B with the Lewis structure for SF5-, molecular geometry, and the bond angles too. Thanks for watching.
12 seconds later.
Drawing Lewis structures, testing time draw. The Lewis structure of methane, CH4. Draw the Lewis structure of methane or natural gas. Number of bonding electrons is equals to 4 plus 1 plus 1 plus 1 plus 1 equals to 8HC. Draw the Lewis structure of put a pair of electrons between each H and the C atom to join them.
Draw the Lewis structure of make it sure each hydrogen has 2 electrons around it and the carbon atom has 8 electrons. Draw the Lewis structures of NH3 and H2CO. NH3, anong yung? Ha?
No. 2,000 years later.
H3 ammonia, as many but using gas, there are 5 plus 1 plus 1 plus 1 equal 8 electrons. When 6 have been used to join atoms, put the other 2 on the central atom.
C of methanol is mainly gas used by be a disinfectant or germ killer. There are 1 plus 1 plus 4 plus 6 equals 12 electrons. When 6 have been used to join atoms, put the other 2 on the oxygen atom to give it 8.
The C atom contains 6 electrons around it. It was 8. So oxygen atom share 2 with the carbon atom. This makes double bond.